Alright, here we go again, dealing with the trigonometry functions. This time it's only about a little after 10 o'clock, so I'm doing a little more, a little earlier in the night. But I want you to get your flip book back out, and we're going to go over some more examples. Hopefully that will help you with your assignment that's coming up today when it deals with the task cards. Now, I will let you know, too, that on some of those problems on your task cards, you still can use your Pythagorean theorem. Okay, and remember, if you have two sides, you can still use Pythagorean's theorem. Okay, so for an example, if you have, say, you have a right triangle, if you have this is a side and this is a side, you can still use Pythagorean's theorem to find this side. Okay, as long as you have two sides, you can still use Pythagorean's theorem. Most of the examples we're going to do at the flip book, none of them have two sides to find a third. Now we may have two sides to find an angle, but not two sides to find a third side. Okay, so these next four problems we're going to be dealing with finding angles. Okay, now I'm probably going to do the first two here, and then I'll probably have you guys to try to pause the video, and then when you come back to it, and after you work it out, come back to it and find the answer. Okay, again, you get your best results if you try to do some of these yourself instead of waiting for me to just put the answer down for you. Okay, it's best if you try to work these out. So in this one, we deal with angle x. Okay, so angle x is the location of the angle that we're dealing with. So remember, based off of yesterday, the location is the key. So within this location, we have, remember, we're still dealing with the opposite, the hypotenuse, and the adjacent sides to that angle. Okay, so this is the location of the angle again. This side is the opposite. The one directly across from the right angle, that's the hypotenuse. And the one that's directly next to it, that's the adjacent. Okay, so now in these that we're going to be dealing with, we're trying to figure out what we need to use. Will we use sine, do we use cosine, or do we use tangent? Okay, so you might want to, still, anytime you do an assignment, even write down on your paper immediately. Sine, cosine is adjacent over hypotenuse, and then tangent is equal to opposite over adjacent. Okay, remember too. Try to remember the goofy thing. Some old hippie caught another hippie tripping on acid. Okay, so when you do so, in this particular problem, you take a look and see what is it that we have. Okay, you'll notice dealing with the angle, we have the adjacent and we have the hypotenuse. So which of these three, sine, cosine, tangent, do we use? We have the adjacent and hypotenuse. The adjacent and the hypotenuse would be dealing with cosine. So let's try to fit our angle using that. Now remember, we talked about, or I talked about yesterday, is trying to find the angle, use the inverse. Okay, in fact, remember, inverse angles, inverse angles, inverse angles. Okay, so we use the sine -1 on your calculator, and then we're going to type in the adjacent, which is in this particular one 31, divided by your hypotenuse, which is 47. So we're going to type that into the calculator. So we have inverse cosine. Huh. I noticed the mistake I made. I'm sure you did too. I wrote sine, and really I should have put cosine. Whew. Man, that could have been bad. Alright, so the inverse of cosine, 31, divided by 47. Then we close the parenthesis, hit enter. So now we have our angle, which is roughly going to be about 48 sorry, I'm writing on the screen here. 48.73. Alright, so we end up with about 48.73 as our answer to this problem. Okay? So now let's take a look at 22. So on 22, angle X is our location. We have, you gotta remember, label your sides to see which one's which. Okay, but first let's identify the hypotenuse, which is directly across from the right angle. So this is the hypotenuse. Okay, then the 22 here is the one that's right next to it. That's the adjacent. And then the one that's directly across is the opposite. Okay, so now we're dealing with the opposite and adjacent. Which of these functions, dang it, which of these functions deal with opposite and adjacent? Okay, you'll notice the one that has the O and the A is the tangent. So we use, the tangent. And again, we're dealing with the inverse. So tangent -1 is going to be, remember, so if we look back, it's opposite over adjacent. So it's going to be 15 over 22, or divided by 22, however you want to do it. And then when we go back, we do the inverse tangent of 15 divided by 22. Close the parenthesis, don't have to, but it's good practice. So roughly be about 34.3, approximately 34.3. And remember, approximate means about, close to. Okay, now I want you guys to do 20 and 22. Pause the video, work it out yourself, and then I'll come back, and or when you press play, I'll bring the answers for you. Okay, so pause it now. Really, pause it now. Don't wait for me. Pause it. I sure hope you paused it so you can work it out yourself and figure it out. On number 20, we have the opposite over the hypotenuse, so that is dealing with the sine. And when you do the inverse, because we're trying to find an angle, you end up with 55.9 approximately. And then on 422, you should end up with 48.4, which is the tangent of the angle, opposite over adjacent. Okay? So now, again, I hope you figured it out, and if you don't, make some adjustments to try to figure out what you did, and then you can learn from that. Okay? So now let's take a look at the sides. So when we're dealing with the sines, it's a little bit different than how we do when we dealing with the angles. Okay, just a little bit. Now we still deal with the location. Okay, so the location is that 38. So from the 38, again, let's identify all parts. This is the hypotenuse, directly across from the right angle. Directly across from the angle we're dealing with is the 38. That is the opposite. And the one that's right next to it, that is the adjacent. Okay, so in this particular problem, we're looking for the adjacent, and we have the opposite. So what deals with opposite and adjacent? Go back and look at your notes, and you'll notice that is the tangent that deals with opposite over adjacent. Okay, so we end up with tangent of the angle 38 is equal to the opposite, which is 13, over the adjacent, which is x. Hopefully, and then remember yesterday when we had the variable on the bottom, remember we switched the two. So you end up with x is equal to 13 over tangent 38. And then from there, we will actually divide that. Okay? So we'll go back to our calculators, and we end up with 13 divided by tangent 38. Whoa, not 388. So then we hit enter. So we end up with about 16.6. So that's what this x is going to be, about 16.6 feet, meters, centimeters, whatever it may be, long. Okay. Let's take a look at number 25. Location of the angle that we're dealing with is the 51. Okay. So let's locate everything. Directly from the 90 degrees is the hypotenuse. Directly across from the angle we're dealing with is the opposite. And the one that's right next to it is the adjacent. So with these three locations, or three sides, we are looking for the opposite, and we have the hypotenuse. Going back and looking at your notes, which deals with opposite and hypotenuse. When you go back and look, you'll notice that which one has the O and the H is sine is equal to O over H. So then we do sine of the angle, which is 51, is equal to opposite, which is x, over the hypotenuse, which is 35. Okay, well from here, we have the variable on top. So to get the x completely by itself, we just multiply by the denominator to both sides. So now we have 35 times sine 51 is equal to x. So then we just type the left side of the equal sign, so we just type in this portion into our calculator. So what we do, we have 35 times sine 51, close the parenthesis, hit enter, and that means the side that we're looking for, that opposite side that we're looking for, is going to be about 27.2. So approximately 27.2. Again, I'm going to pause, so I want you to pause it again so you guys can do 24 and 26 on your own. Okay, pause it. Okay, I'm going to come back with the answer and check yourself. I really hoped you paused this so you could look for yourself. Alright, work it out yourself. If you did and made a mistake, no big deal. We're going to fix it. We're going to get a little more practice. We'll work on it a little bit on Friday, and we'll talk about some of this stuff, okay? But please give this a chance. Give it a chance. Don't just sit and just go like, oh, I don't know how to do it, so I'll just quit. I'll just wait till another day and then waste time. Try it. You learn from mistakes sometimes just as much as you do try getting it right every single time. Okay? So on 24, you should get 7.2 as your side x. And then on 26, you should get 10.3. Because we used cosine, which is adjacent and hypotenuse. And then on 24, we had the opposite and adjacent, which was the tangent. I only have about a minute left to do on this particular free video that software that I'm trying to use. So I went ahead and drew Jack the monkey, and you're basically the problem. I know you're super impressed by what I just drew. However, we got to move on. We'll talk about it later. So in this particular problem, we have the elevation dealing with this angle. We have the opposite here, and the one that's right next to it, which is the adjacent. Which one deals with adjacent and opposite? Is tangent. So you have with tangent of the angle is equal to opposite over adjacent. So in this particular problem, I went ahead and wrote it out for you. It's tangent of the angle, which is 23, is equal to x over 24. And to get x by itself, you must multiply by 24 to both sides. And by the time you multiply both sides by 24, you end up with 10.2. So the pole is about 10.2